See, in this chapter called as atoms, hmm, here we do all for a scattering experiment. What we do? We do all for a scattering experiment. And this experiment is done on gold foil. Is done on gold foil. Why do we use gold foil only? Hmm? See here, if we take a gold foil and pass all the alpha particles to this. These are all alpha particles. Some of them will deviate, some of them will pass through, some of them will return back like this. So why it is so? Because inside the gold foil there are atoms. What are present? There are atoms inside the gold foil. Okay. So I am taking one small example. One atom I am considering here, and this is called as positive. This is called as positive. So what do you understand from this atom? Let us see. So some of the alpha particles will move like this. Some of the alpha particles they go directly and return back, and some of the alpha particles will reflect like this. Okay, so what are you going to understand from this? So if the alpha particle which has to go like this is deviated in this direction, making certain angle theta, which is going to be less than 90, and here the alpha particle which has to go like this is deviated in this direction. Ila povalsindi deviate ila vachindi. It's making angle theta which is going to be greater than 90. And now which is going directly to the nucleus is returning back in the same direction. Understood? So this which is going directly, all are called as alpha particles only. These are alpha particles which are going. So this is the gold foil. Why do we consider only gold foil? Why not another metal? See, gold is such a metal which is malleable and ductile. Which is malleable and ductile. Malleable means what? It can be made into thin sheets. Guddi dan mida thin sheet cheyochu. Because the thinner the sheet, the better will be the scattering. ఎంత thin ఉంటే అంత బాగుంటుంది scattering. Other metals we cannot make thin. If you make thinner and thinner, that metal will break. But the special character, why the gold is so costly? Because ఇంత చిన్న కడ్డీ కూడా తయారు చేయొచ్చు గోల్డ్ తీసుకొని. చాలా చిన్న మన ఎంట్రీకి అంత కడ్డీ కూడా తయారు, బికాస్ ఇట్స్ malleable as well as ductile. Ductile means it can be drawn into thin wire, it can be converted into thin sheets. So gold is the best metal for doing alpha ray scattering experiment. You know what is the meaning of alpha? Alpha means +2 and 4 is going to be the charge and mass number, and with this it is understood that alpha is positively charged. So and even nucleus is positively charged, same charges gets repelled, so it goes in this direction, and when it comes very close to the nucleus, because of deflection, because of repulsion of same charges, it deviates with certain angle which is less than 90. Okay, so this is called as, this distance is called as B. Okay, and this distance is called as R naught. How much close it can reach up to nucleus? Because of repulsion, again it turns back. This is called as R naught. So here B is called as impact parameter. Impact parameter, and R naught is called as distance of closest approach. It can move up to that point. Beyond that, it cannot move. If it tries to move, it gets repelled back because of same charges will repel. Alpha is also positively charged. Nucleus is also having protons which are positively charged. Okay, so B is called as impact parameter. What is the impact? Impact అంటే ప్రభావం. దగ్గరికి పోవడం వల్ల ప్రభావం ఏం జరిగిందంటే it deflects, it reflects, it deviates from its actual path because of B. See, R naught is constant, but B will change. B. So here B is lesser, here B is larger. దగ్గర నుంచి పోతే ఎక్కువ డివేట్ అవుతుంది, కొంచెం దూరం నుంచి పోతే తక్కువ డివేట్ అవుతుంది. If it moves farther, angle is less. If it goes very close, it deviates with greater angle. If it goes directly towards the nucleus, ఏ డైరెక్షన్ లో పోయిందో అదే డైరెక్షన్ లో, the same direction it returns back. 180 degrees is going to be the deviation, and how much close it is going to reach, this is going to be the alpha particle up to where it goes to reach, and the distance is taken as R naught. Okay, so in all this process, you are going to observe one thing. What is that you are going to observe? Here kinetic energy is getting converted into potential energy. Faster it moves, goes to the closest approach, and there it stops and returns back. So where it stops, there total kinetic energy gets converted into potential energy. That is called as conservation of energy. That is called as conservation of energy. So kinetic energy is written as half m alpha v alpha whole square. So according to electrostatics, what is the formula for potential energy? The formula for potential energy is minus q1 q2 by 4 pi epsilon naught into r. You just remember this one. Okay, you just remember this one, that okay. So this is going to be the potential energy. Then here, if you take the nucleus, what is the charge inside the nucleus? What is the charge inside the nucleus? Okay, so the charge inside the nucleus is taken as q2, which is z into e. Ajab. Okay, so here z is the atomic number. Z is the atomic number of this gold, and E is the number of electrons in this. मैंने 7:30 को आया. So this is called as Q2. Then what is Q1? Q1 means it is the charge on the alpha particle, which is taken as 2e. Okay. So Q2 means not only gold foil. If you take some other metal also, if you consider Z of a gold, you cannot apply. Some other metal you take, silver if you take, Z will change. You know. That's the general formula we write Z into E. And for alpha, you know there are two charges. So we write 2 into E. Understood? So what is the potential energy in this case now? Minus. Okay. So minus Q1 means 2E, Q2 means ZE. So 2ZE square by 4 pi epsilon naught into R naught. Okay. R is replaced with R naught because R naught is the distance between alpha and nucleus, which is called as distance of closest approach. So what I am going to do now, this potential energy I will compare with this. Okay. Idem chestarenu. I'll start comparing with this. I'll compare here. Okay, I'll keep like this. Understood? So potential kinetic energy gets converted into potential energy, conservation of energy takes place. That means how much kinetic energy it is having here, totally it is getting converted to potential energy. And the potential energy formula according to the chapter called as electrostatics is this one, where Q1 is 2E, Q2 is ZE. Comparison is going to be like this. Then from that I am getting what is R naught. R naught you take upwards, then minus 2 ZE square by 4 pi epsilon naught into half m alpha v alpha. M alpha v alpha is going to be your formula. Okay, so your formula is ready now. Your formula is ready now. So you got R naught, which is called as distance of closest approach. You got this formula, isn't it? Next, see, distance of closest approach R naught is not going to change, whereas B may change. Okay, so any alpha particle coming very closer may be having greater angle, which is going a little bit far may be having lesser angle. That means impact parameter depends upon the angle. Impact parameter depends upon the angle. Just remember that one. So here, so what is the formula for impact parameter? Same formula. So for impact parameter also same formula. Small changes will be there. What are the small changes? Let us see here now. What are the small changes? Here also we write, here also we write half m alpha v alpha whole square, but minus 2 z e square by 4 pi epsilon naught into distance. I will not take r naught there, I will take distance as b. Okay, and also I write here so it is going to be cot theta by 2. Okay, so same formula for impact parameter also, but extra is angle is coming here because it depends upon the angle. R naught is not depending upon the angle. R naught and any exactly going towards the nucleus and coming back. That is called as R naught. But B is not going to be same. It changes where it goes closer and goes far. Understood? So that depends upon this one. So what do you understand from this? Then what is B here? B is nothing but impact parameter. B you take upwards. So minus 2 z e square cot theta by 2 divided by 4 pi epsilon naught half m alpha v alpha, the same formula but extra is cot theta by 2 is coming. So with this it is understood that B is directly proportional to cot theta by 2. Larger is the angle, larger is the B. Understood what I am saying now? So B depends upon angle. Then from this, what do you understand? What is the relation? What is the relation between? Okay, so what is the relation between B and R naught? Okay, so what is the relation between B and R naught? So B just now I wrote, what is the B actually? 2 z e square 4 pi epsilon naught half m alpha v alpha whole square cot theta by 2 extra. Okay, this is going to be extra now. Here write line cot theta by 2. Okay, so B, is it not the formula for R naught? Yes, check it out. Is it not the formula for R naught? Hmm? Extra here is only cot theta by 2. So with this it is understood that B is equal to R naught cot theta by 2. Is it clear what I am saying now? Is it clear what I am saying now? So I think you understood this one. So here, so in an alpha ray scattering experiment, in a nucleus and a atom is considered. So all the alpha particles will deviate. Some of them will deviate with greater angle. Some of them go and come back, and some of them goes with different angles. These are all called as scintillations. Okay, scintillation means what? Light ray also gets scintillated. Light ray also gets scintillated. Hmm? So when there are some small droplets present on the leaves, you know, scintillations takes place. When on a drop and light falls, it deviates in different directions. It takes reflections, multiple reflections taking is called as scintillations. Okay, so here number of scintillations is inversely proportional to sine theta by 2 whole power of 4. Number of scintillations is inversely proportional to sine power of 4 theta by 2. Number of scintillations. What is the meaning of scintillations? Going and reflecting in different directions. Some of them go and come back. ఈ మొత్తం ప్రాసెస్ ని scintillation అంటారు. Understand? Okay. For example, scintillations are 100. Okay, when theta is equal to how much? 90 degrees. Then when what is the number of scintillations when theta is equal to 60 degrees he is asking. Okay, when theta is 90 degrees అంటే ఎన్ని ఆల్ఫా పార్టికల్స్ 90 degrees తో పోతాయి, ఎన్ని ఆల్ఫా పార్టికల్స్ 60 degrees తో పోతాయి he is asking. So for that this is going to be the formula. N is inversely proportional to n power of theta by 2. So you write n2 by n1 is equal to sine power of theta 1 by 2 sine power of theta 2 by 2 whole power of 4. Okay, so what is this now? Here this is n2 by n1 is given as 100. Okay, is given as 100. Theta 1, let us take this is theta 1, this is theta 2. Theta 1, okay, theta 1 enta 90. So sine 90 by 2 sine 45. Sine 45 is 1 by root 2 divided by sine 60 by 2 means sine 30. Sine 30 is 1 by 2 whole power of 4. Okay, so what do you understand from this? So n2 by 100 is equal to పైకి 2 వస్తుంది, రూట్ 2 పైకి వస్తుంది, రూట్ 2 here 2 by root 2 కదా అంటే root 2 whole power of 4 this one. So n2 by 100 is equal to root 2 power of 4 is nothing but root 2 into root 2 అంటే 2, మళ్ళీ ఇంకో root 2 into root 2 అంటే 2, 2 to the 4. So 4 number of scintillations is going to be 400. Okay, so I hope you are understanding now. This type of problem sometimes it is asked, one time it is asked, that's why I'm explaining this one. So next thing is, what is the radius of an orbit? What is the formula for a radius of an orbit? So here, this is a positive charge. This is going to be an orbit having certain radius. Okay, so now here I have taken one electron here. I have taken one electron. So charge on the electron which is taken as Q2. Okay, if you imagine the charge on single electron is Q2, here charge in the nucleus is taken as Q1, which is taken as Z into E. I didn't take hydrogen. Any atom I have taken, I don't know what is the atomic number of that atom. Generally, I have taken. So nucleus means number of electrons present in that. Number of electrons present. Z is the atomic number, so Z into E. So here, what are the forces acting on this? Let us imagine now. So whenever an electron is revolving around an orbit, two forces will act on that. One is called as centrifugal force, another is called as electrostatic force. Just remember this one. Okay, centrifugal force means any body going in a circular motion, centrifugal force acts, which pulls the body away from the center. And there is one more force which is called as electrostatic force. The force of attraction between two opposite charges is called as electrostatic force. You know about that, isn't it? So I have written now, electrostatic force is going to be equal to centrifugal force. Electrostatic force is, what is the formula for electrostatic force? It is nothing but Q1 Q2 by 4 pi epsilon naught into R square. This is from Coulomb's universal square law. Tells kada my electrostatics లో తెలుసా లేదా ఫార్ములా తెలుసు వెరీ గుడ్ టెన్షన్ పడద్దు అర్థం కాకుండా మళ్ళీ కూర్చుందామా బికాస్ ఫస్ట్ టైం యూ ఆర్ కమింగ్ ఆఫ్టర్ ఇంటర్మీడియట్ ఇట్స్ లిటిల్ బిట్ టఫ్ డోంట్ వరీ అబౌట్ దట్ ఓకే సో ఎలక్ట్రోస్టాటిక్ ఫోర్స్ మీన్స్ q1 ప్లేస్ లో ZE q2 ప్లేస్ లో E సో Z E square by 4 pi epsilon naught into R square. This is going to be mv square by R. mv square by R square gets cancelled. Okay, so R square gets cancelled. What is the formula for R now? R pi potundi ZE square by 4 pi epsilon naught, and this R goes is going to be mv square. Got it? Is it okay? So I got the formula for R now by using the forces. See, both the forces are balanced, then only atom will exist. Electron will revolve. When centrifugal force is greater than electrostatic force, then what happens? The electron will fly off tangentially. If electrostatic force is dominating, then it will fall inside in the spiral direction. Okay, itla lopaliki vastu lopal padipotadi, atom will collapse. But both are getting balanced. Both are equal, so I am getting radius here. But you also know one thing. Let me say what you know already. According to Bohr's atomic model, you also know that mvr is equal to nh by 2 pi. Angular momentum is quantized. This is going to be one of your postulates of your Bohr's atomic model. Angular momentum L is equal to nh by 2 pi, where n is said to be principal quantum number. First orbit n equal to 1, second orbit n equal to 2, and so on. Is it? So from this also I have taken R is equal to nh by 2 pi into mv. This is called as equation number 2. Both are same. 1 is equal to 2. Rendu same. So what I am going to get now? Let us see. When both are same, I will write Z E square by 4 pi epsilon naught into mv square is equal to nh by 2 pi m into v. So ఇందులోంచి mm cancel అయితే చూసుకో ఒకసారి. v square gets cancelled, m gets cancelled, pi gets cancelled, 2 ones, 2 twos. Okay, only one v is left. One v you take that side. Okay, so one v you take that side. So one v you have taken this side. So what is left here? Z E square. Okay, కింద ఏం లేదు అవతల పోవడానికి Z E. So E Z అవతల రాసుకో. Z you write like this. So E square in the numerator. So V I have taken upwards. So here what is left now? 2. 2 is left here. Epsilon is left here. H is left here. And N is coming downwards. I will write N here. So Z by N. So we got the velocity formula as E square by 2 epsilon naught into H. Okay na? So what do you understand from this? V is directly proportional to Z. V is inversely proportional to N. N is called as principal quantum number. So when atomic number increases, Atomic number increases, velocity also increases. When principal quantum number increases, velocity is going to decrease. Means last orbits whose principal quantum number is n equal to 4, n equal to 5, they are having lesser velocities. And the one which are very closer, n equal to 1, which is very close to the orbit, very close to the nucleus, n equal to 1, they are having greater velocities. That's the meaning of this. Okay, so here V can be taken as this one. So the మొత్తాన్ని constant గా తీసుకోవచ్చు. What is that constant? C by 137, which is equal to Z by N, is going to be your formula here. Hope you're understanding the formula for velocity. So what did I do now? I got the velocity of an electron which is revolving around an atom. I got the velocity of an electron which is revolving around the atom here. Now let me find out what is the radius of an orbit. The same process here also. Positive charge is there. An electron is revolving around the nucleus. Okay. So what are the forces acting on this? MM forces act chestayi. E direction lo electrostatic force. Away from that, centrifugal force. This is ZE, this is E, this is Q1, this is Q2. Q2 is equal to E. So centrifugal force is equal to electrostatic force. Centrifugal force is mv square by r. Electrostatic force is Q1 Q2. Q1 Q2 means ZE square by 4 pi epsilon naught into r square. Is it okay? Is it okay? So I want radius now. See, if I want velocity, I have to find out the radius. From two formulas, I have to find out the radius. Make the radius equal, I'll get velocity. But in this case, I want radius. Make the velocities equal now. From this, R gets cancelled. Okay. So what is getting cancelled here? R getting cancelled here. So V square is equal to ZE square by 4 pi epsilon naught into M. This is going to be equation number 1. Hope you are understanding from this. Is it okay? Is it okay? Same formula which I have taken in the last case. Same formula get. There I have taken radius. Radius kuda okati migili untadi kada. Here one radius is also left now. R square cancel, one radius is there. So where is that radius coming now? Here. MR. Is it okay? Is it okay? Equation number 1. See here, one more formula is there. Yeah, what is that? Angular momentum is quantized. That formula also you have to consider. What is that? MVR is equal to NH by 2 pi. So here also velocity, from here also I have to take velocity. NH by 2 pi into MR. This is equation number 1. Equation number 2. See, substitute 2 in 1 now. This V here, if you substitute 1, going to get like CM. Okay. So substitute cheste N square, H square, 4, 2 to the 4, pi square, M square, R square is equal to 2 E square, 4 pi, epsilon naught, M into R. Okay. So what are you going to get cancelled here? MM cancel either. R square, M square, pi square, 4 getting cancelled, isn't it? So last what is left? R is left. So R you take upwards. Okay. So R you take upwards here. So R పైకి తీసుకుంటే ఇక్కడ ఏం మిగిలింది h square, n square లాస్ట్ లో రాసుకున్నాం. ఓకే. సో ఇట్స్ గెటింగ్ దేర్ నౌ. సో వాట్ ఈస్ లెఫ్ట్ నౌ? h square, n square లాస్ట్ రాసుకున్నాం. R పైకి వచ్చింది. కింద ఏమేమి వస్తాయి? pi చిన్న pi is there, m is there, this e square comes down, 2 is also there. అంతేనా? 2 ఏనా? అది z కదా, ఇది z లాస్ట్ లో రాసుకున్నాం. పై z ఇక్కడ రాసుకో. దిస్ ఇస్ z నాట్ 2. ఎందుకంటే z స్క్వేర్ కదా, z ఇంటూ ఈ z స్క్వేర్ ఐ హావ్ టేకెన్, నాట్ 2. దిస్ ఇస్ z హియర్. ఓకే, అండర్స్టాండింగ్ నౌ. ఎనీథింగ్ ఇస్ లెఫ్ట్ నౌ, జస్ట్ సీ. r పైకి తీసుకున్నాం. పై m e square. Okay, so r. Understood? So these are all constants. Only the variables are r is directly proportional to n square, r is inversely proportional to z. The principal quantum number increases, radius also increases. You are observing it from already in Bohr's atomic model. You might have seen that the greater is the radius, the greater is the principal quantum number. Understood what I am saying now? Here, when atomic number decreases, radius increases. So for smaller atoms whose atomic numbers are less, they are having larger radii. That is the meaning here. Hope you are understanding what I am saying now. Why is it so? For larger atoms, Proton number will be more because atomic number is more. When proton number is more, the stronger the nucleus, the greater is the attraction force. Then electrons will come closer, orbits will become shorter. Is it clear? Orbits will become shorter. So this is the relation you are getting now. So from this you'll understand one thing. What is that you are going to understand from this? సో ఆర్ ఇస్ ఈక్వల్ టు ఇది కాన్స్టెంట్ కదా, ఇది మొత్తం కాన్స్టెంట్ చూడు, దిస్ కెన్ బి టేకెన్ as 0.53 n square by z. This is the formula for radius. Hope you are understanding. Got the radius? Yes. So once you get the radius, what is the next thing you have to find out? See, next thing you have to find out is what is the energy of electron. What is the energy of an electron revolving around the nucleus? Let us see this one. So this is positive and one electron is revolving around the nucleus. What is the energy present in this electron? What is the total energy present in this electron which is revolving around the nucleus? For that, what are you going to do? Same process. Here also electrostatic force, centrifugal force, same but slightly different. What is that? Here also you write the same equation. Centrifugal force is equal to electrostatic force. This is ZE, this is E. So ZE square by 4 pi epsilon naught into R square, which is nothing but mv square by R. So what are the things getting cancelled here? Mm cancel avutundi ikkada, R square R is getting cancelled. Em migilindi ikkada, what is left? Not like previous, slight difference is there. Mv square is left and ZE square by 4 pi epsilon naught into R is left. Is it so? So you want kinetic energy. So kinetic energy ante emi half mv square. Ikkada half to multiply cheste akkada kuda half to multiply cheyala. Is going to be ZE square 8 pi epsilon naught into R. Understood what I am saying now? This is going to be the formula for what? Kinetic energy. Kinetic energy formula you got. So kinetic energy formula you got now. Then what is the formula for potential energy? What is the formula for potential energy? See, potential energy is nothing but minus Q1 Q2 by 4 pi epsilon naught into R is going to be the formula for potential energy according to electrostatics. According to electrostatics chapter, this is going to be the formula. So potential energy is nothing but minus Q1 minus ZE square by 4 pi epsilon naught into R. This is going to be the first equation. This is going to be the second equation. Now I want the total energy. I want the total energy. Here, total energy is going to be the sum of potential energy plus kinetic energy. Rendu kalpala. Okay. So rendu kalpite you get potential energy. So from this, total energy is nothing but potential energy. How much? Minus ZE square by 4 pi epsilon naught into R plus ZE square by 8 pi epsilon naught into R. So total energy you can common out here ZE square by 4 pi epsilon naught into R. If you common out, what is left now? Yes, what is left? So minus 1 plus 1 by 2. 2 for the 8 కదా. Okay, minus 1 నుంచి half తీసేస్తే minus half ఏ వస్తుంది మళ్ళీ. So total energy formula ఏమి? Minus ZE square by 8 pi epsilon naught into R, because minus 1 by 2 left. Minus 1 by 2 means 2 for the 8 again. So what is the formula for total energy? The formula for total energy is this one. This is called as the energy formula. Understood? This is going to be the energy formula, but you know there is one formula for radius. What is the formula for radius? So here energy, okay, so energy is equal to how much? Minus ZE square by 8 pi epsilon naught. R place లో ఏమేమి ఉంది అక్కడ? So R place లో ఇది పెట్టుకోవాలి. So what do you get now? H n square in the denominator, then pi m e square z in the numerator. Is it? So what is the formula for energy now? Here e power 4 pi m. Can I cancel this pi now? Pi cancel hota na? Pi can cancel out. So e power 4 m z you write last, z square, in the n square you can write last, e power 4 8 epsilon naught h. అంతేనా, మిగిలింది ఏమనుందా చూసుకో. Is it okay? Is there anything left now? Is it okay? So this is the formula getting. So once you get this as a formula, then here you can write E is equal to here. Minus was also there కదా, total energy అంటే మైనస్ కూడా ఉంది కదా, మైనస్ హియర్ e పవర్ 4 m h స్క్వేర్ రావాలి కదరా, h స్క్వేర్ రావాలి, h స్క్వేర్ ఇక్కడ h స్క్వేర్. ఓకే, సో 8 ఎప్సిలాన్ నాట్ h స్క్వేర్ ఏం చేయాలి తెలుసా, ఇక్కడ hc తో మల్టిప్లై చేసి hc తో డివైడ్ చేయాలి, z స్క్వేర్ బై n స్క్వేర్. ఎందుకు చేయాలంటే ఇది మొత్తం కలిపితే ఏమి ఏదది e power 4 m 8 epsilon naught h cube into c is called as Rydberg constant. Rydberg constant r అది. సో ఎనర్జీ కి ఫార్ములా ఏమొచ్చింది ఇక్కడ మీకు, మైనస్ r hc z square by n square. దిస్ ఈస్ గోయింగ్ టు బి యువర్ ఫార్ములా. అండర్స్టూడ్ వాట్ ఐఎమ్ సేయింగ్ నౌ? ఎనర్జీకి ఫార్ములా ఇదేనా వచ్చేసింది. సో minus r hc z square by n square. Remember this formula now. So once you remember this formula, now it is easy to find out transitions. What are the transitions here? First, second, third, fourth, fifth, and so on. Here, n equal to infinity, n equal to 1, n equal to 2, n equal to 3, n equal to, this is n4, n5, principal quantum numbers. Here, if you observe, okay, so first a transition from here to here, second from here to here, third from here to here, and so on up to from infinity to here. Okay, understood what I am saying now? What is this called as? Lyman series. So this is called as Lyman series. Okay, next from here to here, next from here to here, next from here to here, next from infinity to this point. So where it falls here, this is called as Balmer series. మిగతా అన్ని తెలుసు కదా మీకు, ఎల్ బామర్, Paston, bracket, fund series, ఇవన్నీ తెలుసు మీకు. So how this transition takes place and what is going to be the formula for that? So first thing is, what is this? This is E initial. And what is this? E final. One electron jumps from final to initial. ఇక్కడ నుంచి ఇక్కడికి వచ్చేసింది electron. Okay. So here, whenever electron jumps from higher energy to lower energy level, one photon is released. And this photon is having a formula E is equal to h nu. అంటే E initial minus E final is equal to h nu. And you know C is equal to nu lambda. Nu is equal to C by lambda. Nu place లో hc by lambda రాసుకోవచ్చు. Understood? And what is the formula for energy? RHC z square by E square. RHC కామన్ తీస్తే ఏమొచ్చింది ఇక్కడ, z స్క్వేర్ కూడా కామన్ తీసేసాయి, z స్క్వేర్ కూడా కామన్ తీస్తే ఏం మిగిలింది ఇక్కడ, n స్క్వేర్. ఓకే, మైనస్ కామన్ ఇక్కడ. సో ఏది ఇక్కడ, n ఇనిషియల్ ఫస్ట్ మైనస్ 1 by n ఫైనల్ హోల్ స్క్వేర్ ఈజ్ ఈక్వల్ టు hc by lambda. So hc gets cancelled. So what are you going to get now? Send this minus also inside, then what you will get, 1 by n final whole square minus 1 by n initial whole square is equal to 1 by lambda. And before that, what is present? Before that, r is present and z square is present. For hydrogen, z equal to 1 అంటే ఇది కూడా పోతుంది. సో హైడ్రోజన్ స్పెక్ట్రమ్ గురించి మాట్లాడితే ఇది ఒకటే ఫార్ములా. సో లైమన్ సిరీస్ అంటే వాట్ ఈస్ ద వేవ్ లెంగ్త్, 1 by lambda Lyman series is equal to r into 1 by initial ఏది n equal to 1 ఇక్కడ 1 square minus 1 by n final whole square. So sorry, n initial whole square. n initial అంటే ఎక్కడ నుంచి పడుతుంది, ఫైనల్ అంటే n equal to 1 దగ్గర అన్ని వచ్చి 1 దగ్గర పడతాయి. ఇది మారదు, ఇది మారుతుంది. సో n ఇనిషియల్ ఏమేం కావచ్చు, 2 కావచ్చు, 3 కావచ్చు, 4 కావచ్చు, లైక్ దిస్. This is the wavelength of Lyman series. Just remember only one thing. See, what is the ratio of maximum and minimum wavelength in the case of Lyman series అని బొచ్చోడు సార్ అడిగినారు. What is the ratio of minimum and maximum wavelength? See here, you all know E is equal to hc by lambda. E is inversely proportional to lambda. Energy, E is taken as energy gap. Energy gap is less, lambda is more. So for which lambda is largest, you can just see. So energy gap అంటే first transition if it takes place from n2 to n1, here energy, this is going to be the lambda, which is called as maximum wavelength. Okay, crust నుంచి crust ki maximum wavelength, largest wavelength. When it comes from infinity to this point, wavelength is going to be the shortest like this. So this is going to be the lambda minimum. ఎందుకు when energy gap is more, lambda is less. Understand? So this, if you consider maximum wavelength, what you have to take? Maximum wavelength means what you have to take? Just see. So 1 by lambda maximum means you write R 1 by 1 square minus 1 by 2 square. This is called as maximum wavelength, which is called as first transition. Then what is called as, this is maximum. What is the minimum? Minimum is R. So 1 by 1 square minus 1 by infinity whole square is going to be 0. So ఏం మిగిలింది ఇక్కడ? జస్ట్ R by 1 మిగిలింది. ఎక్కడి నుంచో వచ్చి ఇటు పడితే ఫ్రీక్వెన్సీ చాలా ఎక్కువ, వేవ్ లెంగ్త్ చాలా తక్కువ. But which is powerful? This is powerful. Energy is highest in this case when wavelength is smaller. Energy wavelength తక్కువ ఉన్నది, ఎనర్జీ చాలా ఎక్కువ ఉన్నట్ల, చాలా పవర్ఫుల్ అది. Gamma rays is having least wavelength, highest energy, and if this type of waves will penetrate to your body, it will kill your RBCs. It will damage your body. So whenever some atom bomb is thrown in some place, what happens? Alpha, beta, gamma will come. So gamma is having highest frequencies. Highest frequencies అంటే దగ్గర దగ్గర ఇలా ఉండడం. లీస్ట్ ఫ్రీక్వెన్సీస్, ఫ్రీక్వెన్సీ తక్కువ ఉందంటే వేవ్ లెంత్ ఎక్కువ ఉన్నట్ల, ఇన్వర్స్ రిలేషన్ కదా. అండర్స్టూడ్ వాట్ ఐ యామ్ సేయింగ్ నౌ? So this is about the total chapter which I explained briefly. Now I think you can solve any previous year problem by using this basic concept. Thank you.